G'day guys, Rossco here. This YouTube channel's taken me a little bit by storm. I've had a plethora of questions, feedback, advice, criticism come through on various forms, Facebook, YouTube, with regard to the build of this particular catamaran. I guess it's pretty clear now to you guys that we're well into it. So right at this stage, as I stand here right now, the hull is basically finished. We've completed the laminate of the hull, but it's important I step back and just before I received a lot more comments and criticisms about the laminate as I start to move in the laminating process with the video series, that you understand firstly the laminating schedule, secondly where we're going with this boat, and some of the changes we've made to the original design. It's important also to note that we've actually had these drawings which are based on the original drawings of the Voyager 1270, which was the original boat made back here in Australia. It's actually a Tony Granger design catamaran, design number 86, which came out back in the late 90s. It was then commissioned by a gentleman called Peter O'Brien as a sail cat, where he, I don't believe he ever really got it into production. I think they had some flotation issues which we're going to deal with as we go along, and that's been brought to light thankfully through YouTube. We also know that it was then purchased by Voyager Catamarans in Queensland, and that boat in fact did make quite a few. I think they made about 3 of these boats before the boat being decommissioned or set aside. Obviously there was issues with production or something we don't really know. It was around the time of the GFC, around the time when Australian boat building tended to move to Asia and overseas for obviously cheaper labour, cheaper manufacture, and then at the end of the day, this seems to be a natural progression in this industry. What I will say though is by having the original plans and engineering that I received with the purchase of the mould that I received, I was able to then go straight back to the original surveying body, which is Oceanic Yacht Designs in Queensland, and discuss with Chris and Scott, the guys up there, how we could bring this boat back into Australian survey. So Australian survey, what that means is the Australian Maritime Safety Authority govern the standards, and they also govern the construction, the usage, and what you can do and what you can't do with a certain boat once it's brought into survey. If I was building my own boat without any intention possibly later on and leaving room for me to be able to possibly charter it, to possibly give it to a charter company to operate, that's a different story. I can go and build whatever I like. Now, being a fiberglasser and having built and canoes and kayaks and done a lot of boat building repairs, I'm pretty comfortable with laminating schedules. The issue is with a boat of this size, when you're looking at around about 8 tons, 8,000 kilograms dry weight, is that once you start to increase the laminates, you can easily develop a lot of weight. So we went back to Oceanic, and these drawings here are the culmination of all those discussions. And it's important, and what I'm going to do through this video is I'm going to actually bring up the PDFs of them so you can have a good hard look at them, pause them, have a look at the schedules. Here we have a laminating schedule, here we have a bulkhead and road partition schedule. This here is our foam outlines, where we'll be placing foam, why we'll be placing the foam in those areas. Here is actually a section of the boat cut from the end, so you can see the foam in here. So I'm going to zoom in on these and hopefully you'll be able to get some feel for the way that I'm going to laminate this boat. Now, having said that, nothing is set in stone, and things obviously need to be changed as certain things go along. But when I lodge these plans with the Australian Maritime Safety Authority, they then have to be ratified, and then there is a surveyor who we've engaged, who comes down at certain intervals in the build process and does an inspection. I'm happy to say we've passed 2 out of the first 2 inspections, the first of which was a site inspection, where David came down from Sydney. It's about 2.5 hour drive. Spent about 3 hours with me outlining firstly site, build process, cleanliness of storage, correct storage, work health and safety issues. There's a whole gambit of things that we needed to do to obviously to get started in the survey process. The second AMSA inspection occurred just after we'd finished a tie layer. In fact, the first 2 layers. That tie layer, or what you'd call a skin coat in the US and Canada, is essentially a very fine layer, and in our case it's 300 grams per square metre of fibreglass matting. And what that does, it physically bonds to or chemically bonds to the gel coat surface, and that's why it's important to do it within the first day after gel coating, to give you a good sort of workable surface, and then you're building your laminates up on top of that. The laminating schedule, as you can see here, which I'll show you in a moment, is quite rigid. It's set in stone. There is no alterations to that laminating schedule, and very, very important that we follow this to the letter of this particular plan, or my next inspection, which is around 80% of the completion of the hull. I won't be able to pass it because we'll be doing a thickness test. We'll be doing a destructive test where we're actually destroying and scientifically pounding it, hammering it, putting load on it, and if we fail that test, then no survey for Ross's boat. So at the end of the day, that system, which is a government body, basically controlling and limiting what can and can't be done with these boats and how they're built, is really going to keep me honest, I guess. I'm a pretty honest guy, but at the end of the day, by building it to a very, very rigid standard, I know that I'm going to get a really nice boat out of it. Now I'm going to start here by showing you this diagram here. This is basically the laminating schedule, and essentially what this shows is different areas of the hull. So up here we've got up on the gunnel leading down the hull side. In fact, this is the port and the starboard side have the same laminating schedule. Down here we've got the chine that I have, and I have quite a significant chine just before you head down into this is around about waterline here. So this schedule here is again very, very detailed. Obviously this part here is in the bottom of the hulls. So we have solid glass along the keel line for 30 centimetres or 150 mil either side of the centre line, and then we have 30 mil H80 Garrit or Divinycell foam. Now this foam here wasn't in the original plan. The original plan was solid glass, and this boat actually weighed in around about 8 tonnes dry weight. That's before putting fuel and water, etc. We're aiming to knock around about a tonne out of this boat, and a tonne meaning around about 750 litres of resin, possibly with the extra laminates I wouldn't have to put in there. And you know, we worked on around about 600 kilos to 800 kilos, and you know, hopefully with a couple of other innovative things with the way we do the internals, we should be able to knock out a significant amount of weight out of this boat. Over here we're back at the chine up onto the chamfer panel, which we have here. So this is the chamfer panel. And then back again up here onto the bridge deck. So you can see up the top here, we've actually got a 30 mil foam, and then mitering into a 20 mil foam here. Now, very important that we look at these all in their entirety, because they all have a different schedule. Now here we have 300, 300, 300, 1040 quadraxial, 1040 quadraxial, 300. Then a core of 30 mil down in the hull, another layer of 300 chop matting, then another 600 double bias, another 600 double bias, and then a 300. So it's a fairly substantial layup, and works out around about sort of 38 mils thick. So that's a fairly, you know, this area here would be probably around about 38 to 40 millimeters thick. So pretty substantial strength, and obviously the same over here. Now, on the diagram you're looking at now, which is actually the PDF of this, so it's better than me pointing at it, we have, you'll notice that there's 300 chop strand matting as the initial tie layer, but then 300 here starts at 150 from the centre line and goes to the starboard side, and then we have 300 starting at 150 mil to the starboard side, which then goes to the port side. So we have an overlap. You can see that here in the first 2 layers, and then again we have another overlap of the 1040 quad and another overlap of the 1040 quad going the other way. So we're overlapping and we're doubling up the strength in the hull line or in the keel line right here. It's such an interesting diagram, this, because I'd never actually seen one so detailed as this, and this is what you get from an engineer when you have an Oceanic or when Oceanic do a design for you. The core, you'll notice also, this core being H80 foam. H80 stands for 80 kilograms per cubic metre. This is a structural grade Lloyd's rated foam. It is incredibly stiff. The issue with that is curving it to the hull here. We had to buy a product called Grid Score, which has actually got about 1-inch blocks, and that actually conforms with a scrim on the outer surface, which is actually like a fiberglass matting, allows it to conform to any shape down here into the keel line. So this goes all the way up to almost to the chine. You'll notice also that there's a 2-to-1 bevel here, and now that bevel there is for strength, but it also allows you to get a nice clean glass layer down here into the keel line, again up here onto the chine, and then we have solid glass in the chine, and then we're back to another 2-to-1 ratio for the hull sides. Now the hull sides, you'll notice, are actually thinner than the keel line. They're a 20mm H80 foam, same type of foam, and then all the way up to the top here. Now, basically this is the gunnel once again. Very interesting that this particular panel here, we notice we have 8 centimetres here, or 80 millimetres, and that 80 millimetres allows me to have solid glass and really get a very, very solid strength of laminate here, and that's this section you'll see in the middle. So the cross section through the middle here is what you see here, and I'll try and zoom in right now on the chine and on the whole keel line, so that you can actually see right down in here, you can see the actual layers in the diagram and how they conform. So you'll see they actually conform right underneath the foam here. There's an area here where you've got it under the foam, and I'll try and show you an image of that right now. You have a look right there. That's the one right there underneath the foam. You'll notice that overlap actually ends there. So that's this one here, that 1040 quadraxial. Now, in Australia here, 1040 quadraxial is quite difficult to buy. So we've actually upped this to 1215 per layer in these 2 layers. So 1215 grams per square metre. It's a 4-layered fabric, where one layer goes vertical, the next layer is at 45 degrees, the next layer at 45 degrees, and the other one is horizontal. So you've got 4 layers of stitched fabric that creates an incredibly strong substrate, which is then laminated in. So in effect here, if you look at this, we have 600, 900, say 2000, 3000, 33, 3500, 3800, 4400, 5,000, 5,300 grams per square metre in the hull, and that's how you factor this in. Now you notice basically that strength there, being solid glass, allows it to be easy to be repaired. Secondly, it also gives you a very, very, very strong substrate, but you haven't carried all the weight up into the hull side here. Essentially, you've gone for a lighter hull side once you get up towards the top of the waterline, obviously removing weight where you don't need it. It also gives it an incredibly strong feature here, and this light is likened to an I-beam, where you've got a foam sandwich construction, and the shear forces on the outside, or the shear testing that's done on these foams once they're laminated in, is quite remarkable. So translating the diagram we were just looking at to this diagram, obviously this is our bridge deck, which is cross-section D, and then we have C, which is our chamfer panel, or in Australia here we call it a knuckle, and then we've got this chine here, and then down into the hull side. You can actually see the cross-sections of the foam. Now on my boat we have 30mm on the bridge deck, 20mm on the knuckle, or the chamfer panel, solid glass on the chine, 30mm, obviously grid scored down in here so we can get that conformity of shape. Solid glass on the hull, 30mm coming back up the outer port side here. Solid glass on the chine, and again 20mm above the waterline. So not only does it give the boat flotation, but an incredible amount of strength. So these sections here, so section 5 is in fact this one. So this one here, you'll see that's section 5. So now if we look at the cross section of this, we have 300, 300, 1040, 300, 1040 down underneath the foam, so it ends there, the foam overlapping the quad, and then 300 over the top, 600 double bias, 300 CSM, and then another layer of 600 double bias over the top and up over the gunnel. Now that gunnel there is a flange here where the deck will sit down onto, and then we'll be glassing the inside of that with a laminating schedule as well. So that is a substantial amount of laminating. I'm actually doing it by hand. Very interestingly, to do it as a vacuum bagged or infusion boat as a one-man operation is nearly impossible. You'd need to have a team of probably 10 people to get this organised. I'm hand laminating every moment of this boat. When determining laminates like this as well, Australian Maritime Safety and engineers take a good look at the chemicals you're using. ANSA requires, as the Australian standard, to have the first 3 layers in vinyl ester resin, and subsequent layers can be in polyester as they go along. Now I've chosen, for a matter of convenience, but also there's reasons why I've done it, is I've chosen to do the entire hull in vinyl ester. We started off with what we call a winter grade vinyl ester, and that is made for the cooler temperatures that we experience here in Jervis Bay in Australia. In winter, it has a slower gel time, so it's around about a 21-minute gel time, just because it gives you good working time, but it allows for the correct catalysation. Now, as we've moved into September and October, we've gone into a summer grade, which has actually given me around about 40 minutes of gel time. And the advantage of vinyl ester is it has a couple of advantages. It shares the epoxy backbone from a chemical point of view. It sort of is a modified epoxy resin. Now that modified epoxy also exhibits a lot of the strength characteristics of epoxy. It's not quite as good as epoxy from a point of view of strength, but what it does do is it does actually inhibit corrosion. So fortunately with a boat of this size, now a boat of this size done like a kayak or a runabout type boat is going to sit in the water for hopefully the rest of its life, and that could be I guess 50 years. Osmosis is a massive problem where the water actually ingresses into the fiberglass and the weave of the boat. With vinyl ester, you're virtually eliminating any possibility or to a degree of osmosis problems. Because it is in fact a barrier coat, and that barrier coat is not able to accept water. It's very, very good at resisting osmosis. So that's one of the main reasons. Obviously there is a price penalty. It's about double the price of polyester, and it's around about 2/3 the price of epoxy. So you're sort of in the middle. You have polyester, then vinyl ester, and then epoxy. I find vinyl ester a lot easier to work with too. It is probably one of the better ones from a point of view of styrene emissions. It's definitely better than polyester. It has less styrene content, and that means easier to work with from my point of view, but actually less airborne styrene. And you know, a lot of boat builders are moving to this for that reason, that aren't using epoxy, purely because councils and government bodies are starting to crack down on the amount of styrene that we're putting into the air. The flashing off of the styrene tends to be a lot nicer on the nasal palate, if I like to put it that word. I've noticed since I used a polyester or iso polyester gel coat, we did have quite a lot of styrene content. It was pretty pungent while we did that gel coating spray up, but then once we moved into vinyl ester, it was nowhere near as toxic and nowhere near as pungent as the gel coat. Now moving on to the foam templates that we have, you'll notice here, and I'll try to zoom in once again, but these diagrams here, this one and this particular one, and this one in fact, outline where the foam is in relation to the section. So here we have the port hull side. You see this dotted line here. I'm trying to avoid shadowing it. That is the section of foam that I intend to put on the side of the hull, and then again under the hull. Now this is actually on the outside, obviously the port hull side, and then this is obviously the starboard side. So as you can see here, we've really got quite a substantial amount of foam going down into the skeg here, and essentially running 8 centimeters from the outside or the outer perimeter of the hull, or the gunnel, and in fact the chines, allowing us to go back to solid glass at that area. And then in the respect of the inner panels, i.e. the chamfer panel, the inner hull, or the tunnel hull, you can see in fact that the hull form foam actually starts here down at the stern, comes along, then joins around about here, about where the knuckle is, and then goes back along to the stern again. Now this is 20mm foam at the top, blending into 30mm foam at the bottom. So hopefully that's all starting to make sense, and that these typical outlines, very importantly, that's your out hull, your whole outboard profile. These have to be put in place and obviously glassed into place, and I'll be showing you at length these videos how we've done this. In fact, we're a little bit controversial in the way that we're doing it, but working on my own, I've had to come up with the best solution, and I've taken a lot of advice from the chemical manufacturers and from the foam manufacturers, and in fact Allnex and Nuplex, which are our major supplier here in Australia. I can't quite get used to talking to myself and presenting this stuff. You know, I've been an instructor in scuba diving and sea kayaking for the last 25 years, but I've never realised until I started watching these videos how penetrating my voice can be. So I really do apologise if you find it a bit grating, but I am trying to get as much information out there so that you know, I can engage with you guys and have a bit of interaction, because that's what I'm doing it for. I'm really enjoying the fact that I'm getting some really good feedback, and the feedback I'm getting and criticisms, comments. You know, it's quite rewarding. It's almost as rewarding as building the boat itself. It's actually given me a whole other hobby, to be honest. So I thank you for joining me, and if you're interested in this, please subscribe, lock down and share it out, and yeah, next time I'll see you on Life on the Mold.